All right, let's do it. Welcome to the Daily Space Weather. We got a coronal mass ejection watch and a solar flare watch in effect. Check it out. Here's the sun in 304 angstroms ionized helium. And we saw coronal mass ejection come out of this new active region. I believe it was from down here in the southeast. And we're going to show you details of that momentarily here. We've got another sunspot rising also, and this new sunspot up here in the northeast, that's actually a beta class sunspot, significant possibility for major flares out of sunspot 2842. It's got complex fields. Here's a quick zoom in. I would also note this sunspot down here very far from the equator, indicating a young cycle as we see sunspots at higher latitudes, like down here, at the beginning of cycles, and at the end of cycles we see sunspots closer to the equator. So let's go out to Lagrange point 5 and take a look at the view from stereo A to check out that coronal mass ejection. And here it is. This is the stereo A spacecraft located at Lagrange point 5, and for you new viewers, from this perspective Earth would be off in this direction. An indication that coronal mass ejection is not Earth-facing in the slightest. Kind of like the last one that our viewers were complaining about other channels crying wolf and basically lying to their viewers. Yes. Apparently, when it comes to things like disaster forecasting, there are a lot of hacks on YouTube. Hack frauds, scammers, hucksters, charlatans, phonies, frauds. Let's look at Lagrange point 1. So at Lagrange point 1, we've got the SOHO spacecraft, which includes the LASCO C3. And here you can see from a more earthly perspective, again, Lagrange point 1 is located right between the Earth and the Sun. That's L1. And from this perspective, Earth would be behind you. And you can see that coronal mass ejection nowhere near the Earth, going to miss to the west, and again, it's on the opposite side of the sun. So now when we forecast coronal mass ejections, we only forecast them for this area, a little bit over the poles, but not on the far side of the sun. We don't forecast these coronal mass ejections, only these coronal mass ejections. And let's take another look at, again, that's Lagrange point 5 now, stereo A. So here's this diagram to show you the locations of those. Here's another composite image. This is 3 different ionized iron spectra, the ultraviolet spectra of some different ionized states of iron, 335 angstroms, 193 angstroms, and 94 angstroms, all in the same imagery. Fantastic imagery there from the Solar Dynamics Observatory. Here's a colorized magnetogram, and you can see the complexity of these fields here. Sunspot 2842 especially has the kind of magnetic fields associated with major flares. So again, don't be surprised to see an M-class flare or an Earth-facing coronal mass ejection. That's why we have the watches in place. Here's a diagram of where things are located in the solar system. We'll advance this 1 week. And there's your astrography for the next week. The 10.7 centimeter radial flux now at 83. And you can expect it to continue to rise as there are 2 significant sunspots rotating in on the eastern limb. Here is the 1-year chart of the radial flux. The black line is the 10.7 centimeter radial flux, the most proportional data set to sunspot number, which is this red line, that data courtesy, solon.info. Space Weather Enthusiast dashboard, NOAA not including any incoming geomagnetic storms or geomagnetic unrest, calm conditions in the forecast. And let's talk seismicity. Check out the earthquake drought over the past 90 days. Look at all the red bars. In last year, you can see how often we see 7 magnitude quakes, once every about 3 weeks or something like that. And now we've got only 1 in the past 90 days. have an earthquake plan if you're in an earthquake-prone zone. Earthquake droughts end in earthquakes. So let's scroll up the list here. No major quakes over the past 24. In fact, it looks like a lull in earthquakes. Largest was, I think, this 5.8 at Papua New Guinea. There's a location of that one. And we're just going to continue up the list here. Looks like continuing activity here around the California-Nevada border. There's another 5.7 at Papua New Guinea, so that's the most active place for sure. There's another 5.7 there. Japan saw a 5.1. A 4.8 looks like an aftershock at Papua New Guinea, perhaps things calming down there. 4.3 at Greece also here. And Etna has been erupting. Let's check the volcanoes. VolcanoDiscovery.com's list. Etna's produced a 20,000-foot ash plume here. And Strombolian activity, another paroxysm from the Sicilian volcano, one of the larger ash clouds it's produced. Sinabung on the Isle of Sumatra, Indonesia, 12,000-foot plume created as it exploded. Popocatépetl in central Mexico now back on the list. After almost 1 month of calmer than usual periods. 74 emissions of water vapor gases and small amounts of ash. I don't know what's small about a 19,000-foot ash plume, but Popocatépetl has been exploding, recording at least 457 minutes of volcanic tremors. Fuego in Guatemala. Moderate activity remains there. It's producing a, I'll say, 16,000-foot plume of ash. Nevado del Ruiz, volcanic ash not seen in satellite. Don't assume it's not erupting. And try to do a square dance around the caldera. Sangay exploding, producing a 20,000-foot ash plume over Ecuador. Sabancaya intermittent puffs produced over Peru. And Nevados de Chilean sporadic emissions are a reminder not to pole vault the caldera. Here at smAsho.com, Smash staff and I prefer our viewers to be healthful as we need the views on YouTube. So please do not pole vault the caldera. It could be unfortunate. This public service message brought to you at massive personal risk and expense from smAsho.com. Visit the links below the video and support our channel. The GOES X-ray flux here over the past 3 days, fairly calm actually, although we did see 2 C-class flares late in the day yesterday, one around 1900 and one around 2100, just before 2100 hours universal time. 2 C-class flares, probably associated with that coronal mass ejection. No proton spikes, no coronal mass ejections have been striking Earth lately. We would have probably let you know beforehand had there been some on the way. GOES magnetometers looking a little bit wild and spiky here over the past 3 days. And you can see some recent wild spikes for you new viewers, the N's and M's. Those stand for noon and midnight local time for the GOES 16. Next, more about the magnetic environment. Here's the heliospheric current sheet. Earth is solidly in a North Pole current sheet. And we've got a significant sunspot in the north and the south on the eastern limb. I would expect Earth to remain in the North Pole current sheet. Just keep in mind the magnetic environment can suddenly change with basically no warning. Here's another view of the same data from the line of sight perspective. It also shows you the solar magnetogram. Strong magnetism associated with sunspot 2842. Don't be surprised to see strong flares. And the line of sight coronal hole plot showing us some coronal holes here. North Pole oriented ones in green, South Pole oriented ones in red. Not very holy when it comes to coronal holes. So here's your flare probability prediction thingy on the Integrated Space Weather Analysis Center. It's right on the solar tab if you want to monitor this yourself. And you can see slightly increased likelihood of things like M-class flares, as we've been saying on the channel for a couple of days. KP index currently at 2. Geomagnetic conditions are calm. That's what the KP index is, by the way, a measurement of global geomagnetism. Next, real-time solar wind. And we've seen a shifting BZ here over the past about 12 hours. The BZ going back and forth from about -5 to about +4. So quite a bit of swinging around there with the magnetic field of the sun. Recent shifts in the phi angle also, as well as some possible errors there in the solar wind data. Anyway, current conditions reported as 5.88 protons per cubic centimeter for the solar wind density, solar wind speed 447 kilometers per second, a slightly elevated solar wind speed. Let's take a look at magnetohydrodynamic pressure in the geospace. This geospace magnetosphere movie should contain 4 hours of data. And we are seeing some pulsations here in the pressure. We'll let this play through as we don't edit the videos to get them onto your screen as promptly as possible. So we'll let the 4 full hours play here. And you can see some variations there in the pressure. And a shifting BTBZ as well as shifting solar wind density or speed can all cause that. Next, looking at ground magnetic perturbations, here's geospace delta B, changes to Earth's B field. We showed you the suns. Here are changes to the Earth, geospace delta B. When you see delta in science, folks, it means change in. And like the last frame, this is 4 hours of data. They're both courtesy of University of Michigan. We show it daily because the archival data is not yet accessible to the public, at least not that we're aware of. So some perturbations happening there. And I would remind all of our viewers to press like and subscribe, share the videos with your friends and foes. We don't think the algorithms like us. And for you daily space weather viewers, we just recorded a cosmology segment. We streamed it live. Make sure you check that out if you haven't. It'll be premiering after the daily space weather video. And let's look at electrons. We don't see any charging hazards. Here's the 1-year chart of the electron flux from solon.info. Moderate range here. Here's a 3-day chart. Slightly low levels of electron flux here, nothing to write home about. Let's take a look at the forecast model, expecting flat levels of electron flux, at least from the NOAA forecast. And here's the diagram of the Van Allen belts. Distance is shown in miles. And here's the total electron content forecast, and we see anomalies once again. I paused it right here because we saw some significant electronic anomalies here starting around 1600 Universal Time yesterday. You can see here in the southern Indian Ocean, south of Africa, and then south of the Atlantic Ocean, and ending south of South America. This area right down here, that's like an additional Van Allen belt here around the South Polar region. Anyway, what this is showing you is the electron density. If you're a new viewer, it's showing you the electron density for the entire air column all the way up to your GPS satellite located at tens of thousands of miles of altitude down to your GPS handset. It'll show you where errors are most likely to occur. And we don't expect to see errors all the way down there in around Antarctica in the southern hemispheric winter. But there are the anomalies nonetheless. Here's a diagram of the atmosphere showing you where the F ionosphere layer is, located at about 300 kilometers of altitude. That red F is the F ionosphere layer. And let's take a look at an animated ionogram showing you this time vibrational frequency of just that slice of the atmosphere. And the vibrational frequency here is in megahertz, millions of vibrations per second. And we're seeing anomalies here once again over North America and the Pacific Ocean. So some surprisingly high vibration zones here. You can see right around this moment. Not super extreme though. Here's the latest image. That's 8:45 Universal Time. Things looking a little anomalously there as well. A little bit anomalously looking ionosphere. By the way, we do meteorology segments as well. Make sure you check those out. Today's will be a separate video. And for all you space weather enthusiasts, if you're Earth weather enthusiasts also, check out our meteorology segments. Let's do our bonus features, starting out with the latest imagery from the Lermonth ground-based solar observatory. Again, we've got a solar flare and a coronal mass ejection watch in effect, folks. We've got all kinds of filaments, multiple sunspot groups, multiple beta-class sunspots. The most likely one to produce major flares is this one up here, 2842. Although this one up here also now has two different polarity umbrae, so that could produce major flares as well. Here's the latest intensity gram. And this sunspot rising down here, that's an alpha class. This one up here is now a beta class. It's got quite a lot of umbrae there. And there's 2842. That one is significant in its likelihood for producing major flares. There are the magnetic fields. You can see multiple fields there. There's that one, now beta class. And this one down here still appearing to be alpha class. Here's the thematic map from the GOES 16 SUVI. It's almost like cheating. It shows you all of the relevant things. I see you can't see the pink. The pink is flaring. That's X-rays, folks. And here's 171 angstroms. We'll show a close-up here, and then we'll zoom out. Thanks for tuning in to the Daily Space Weather. Congratulations on realizing our channel exists. Please tell your friends and foes about us. We've barely even begun to create content. Press like and subscribe if you enjoy it. And may that solar wind be at your back.